You're given an integer array cost where cost I is the ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step with index 0 or the step with index 1. Return the minimum cost to reach the top floor. Okay. To give an example, cost equals 10, 15, 20, output is 15. You start at index 1, pay 15, climb 2 steps to reach the top. So in here you can just simply do a 2-step, 15, then once another 2-step, you end at the top. So that's why the output is 15, right? You don't want to do a 1-step and then 2 steps, so obviously you'll get greater than 15. You want to find the minimum cost. So given this example here, this one is a longer version, the output is 6. So what you're doing here is basically start with 1 on the first step, and then you go 2-step here, so you got 2, and you have another 2-step, you got 3, you have another 2-step, you got 4. You don't want to do a 2-step because it will become 100, so you do a 1-step, so it becomes 5, and then you do another 2-step, it becomes 6. That's why the output is 6. Yeah. So this problem as well, you need to do some dynamic programming here, and basically I'll show you how you do this. You're solving dynamic programming. So first step is you need to have a table. When you do a dynamic programming problem, you normally have a table to represent your structure, and then this is your input, right? So the base case is you need to find out a way where, how do you compute this, the third position? Yeah, the minimum cost on the first one. The minimum cost on the first one is always 1, right? The minimum cost on the second iteration is always this. The second step, it's always 100 because the second step costs 100. How about the third step? So this is where you start thinking, how do I compute that, the calculation for the third step? The third step is computed based on the previous one and this 1 and 100, right? Because you can only do 1 or 2 steps. So what you really need is to find the minimum between the previous two. So once you found the minimum, you can just simply add the cost to that minimum. So you know that cost for this iteration will become 2. Same with here. If you go here, you find the minimum cost between the last 2 steps, and then you add the cost on top of that. Eventually, you'll have a table something like this. So we'll just go through it, iterate it once, and show you how it works. So for the first step, obviously here, 1 is 1, 100 is 100. So because the first 2 steps is obviously 1 and 100. Now when you go to the third step, you can either select between this 1 or 100. The minimum between 1 and 100 is 1, right? And you just simply add the cost of 1 here, so it becomes 2. On the third step, it's between 2 and 100. The minimum is 2. You add 1. The minimum between the minimum 1 to 2 is this becomes 3. Yeah. So because this is 1, the minimum between 2 and 100 is 2 plus 1 becomes 3. On the fourth one, the minimum between 2 and 3 is 2 plus 1 is 3. The fifth one, the minimum between 3 and 3 is 103. Between 3 and 3 is 3 plus 100 is 103. The minimum between 4 and 103 is 4, definitely. And then you add 1 because 1 is the cost of the 5th iteration. That's why it becomes 5. Now you go to this one. 4 and 5, the minimum is 4. Then you add 100 to that cost. You have 104. And then you go to the 10th position, which is 1, right? So the minimum between 5 and 104 is 5 plus the cost, which is 1. So you got a 6. So if you want to find the top or the end of the stairs, you just simply have to find the minimum between 104 and 6. So you got a 6. Yeah. So this is how you construct a table from bottom up. Sounds counterintuitive, but once you figure out like the structure, how to do this, it's much easier. So what we're gonna do is try to code this one here. So say var, and just store this in the variable. I'm gonna use Java here. Then var, put a table. So we need a table to store our minimum cost. Let's store the minimum cost table. Okay, so the first two minimum cost is obviously it's itself. Second one is 1. Starting forward from I equals 2 is less than n. So we calculate the minimum cost of I position. because ith position is the minimum between the last two. So you just do something like I minus 1, no, minus 2, plus the minimum between this one, minus 2, plus the cost, which is itself. Right. Then you return the minimum between n minus 1 n minus. Right. So let's try it out. Memo. Yeah. Okay, this one is 15, so you're at the bottom. You basically find the minimum between 15 and 20, and you pick 15. Submit it. There you go, 100%. So this is how you solve this using dynamic programming. Typically, it's quite counterintuitive, but you can also do this using top-down approach, but I would prefer using bottom-up. Once you figure out how to build the table, it's not that hard. So the base case is actually trying to find the minimum, and that's your base case. Like you're just trying to find the minimum, storing that minimum value in the table, and computing the minimum on top of the table. So yes, this is how you solve it. If you like this video, please hit like and subscribe, and don't forget to drop a comments, anything you want to put in the comment section. Thank you for watching, and see you again in the next episode.